Thank you, John, for the introduction. So I'm Tim Verbelen. I'm a researcher at Ghent University. And Jan?
I'm Jan Rellermeyer. I'm assistant professor at TU Delft in distributed systems.
And today we're going to talk about remote management and monitoring of OSGi, and especially in distributed OSGi applications. And John was mentioning the R7 spec, so we will touch upon two specifications. One was already there since R6, and the other one is actually new from R7, which is the cluster information specification, but more on that later. So remote management and monitoring is kind of, you just need it, right? So either you cannot go on site every time to inspect your device and to check whether everything is still running, or it's very hard to kind of attach a screen or an input device to one of your devices. Your device may be unreachable. We heard a keynote from ESA. If you have like a drone on Mars or a rover on Mars, it's hard to kind of go out there and see what everything's still running. Or there might just be too many devices out there in the field that you cannot just go out there and inspect all of them. And remote management is actually a topic in OSGi in particular, because
yeah, so since you made it to an OSGi session, I assume that you're all intimately familiar, but just in case not, OSGi is mainly an advantage to you from a software engineering point of view, right? Because it is, in my opinion, the modularity framework for the JVM. And it makes your life easier because if you don't have modularity in your project, you end up with a monolith that is very difficult to maintain, very difficult to evolve, and can create lots of pain in the long run, right? So OSGi, the main contribution to me is that it introduced this module way of thinking, where you can contain your code into different modules, and then you have a choice between those modules who are tightly coupled because they strictly depend on each other, and that you can express through packages. And then you also have the option to loosely couple modules through services. And that, for instance, opens the door to have optional components that can come into your framework and extend the functionality at runtime, or having some one-to-many relationship where you have multiple implementations, and you can pick at runtime which one works best in your environment. But from a conceptual point of view, to me, especially from a distributed systems point of view, it is really that you start to embrace dynamism, right? Because in an OSGi deployment, things are not static. You should not assume that they are always there. In fact, you can individually manage them at runtime. So embrace change and use it to your advantage. And it's not surprising that this is one of the main features of OSGi, because it all started in the world of these television set-top boxes back in the days where people thought that this was the smartest device that we would ever have at home, right? Long gone. But the main challenge that was addressed in OSGi was the problem of having very long-running devices that are potentially even managed by a remote entity. For instance, a telco or a cable television provider. You deploy them at home, and then you rely on these services to update them occasionally, right? And in those days, we still were using things like Windows that required a full reboot of the entire system every time a little component changed. And to be fair, at least operating systems tend to still be of that kind. If you change something significant enough, then just go back to square one and reboot the entire thing. So OSGi had this nice feature that you could only reboot the subset of features that was actually affected by an update. And by exposing the structure of your modular application, expressing dependencies, the framework would even be smart enough to find out for you what needs to be restarted and what can just remain to be running. And therefore give a more uninterrupted user experience to the end user. So unsurprisingly, in view of where OSGi came from, there were actually relatively early efforts to standardize on the idea of remote management.
Yeah, exactly. So there was already back in the early days like the TR-069 protocol, which was actually a protocol created by those telecom providers and companies creating set-top boxes to kind of define a protocol of how to manage these devices. And actually OSGi then also made an effort of creating a spec out of it, of how can you integrate such a protocol in an OSGi space. And they went even a step further and say, okay, there was not only TR69, but there was also UPnP and lots of other kind of discovery management protocols out there. So they created the device management tree spec, where you basically had like tree-like structure where you could kind of plug in all kinds of protocol adapters and kind of see how all devices out there behave and whether they're still working. And it's still used in the IoT space. So I think that, for example, Bosch still has some products based on this spec out there. But then, of course, REST came along, and that was like suddenly the new way of remotely making a method call to some device out there. So
yeah, so interestingly, both the REST effort and the cluster information service effort originated from the same RFP, I think, back in the days when I was still an invited researcher of the OSGi Alliance, so already almost a decade ago, I guess. There was this idea that we should take OSGi to the cloud, right? Because the cloud has a lot of these same constraints that you have to continuously update your software and evolve and have dependencies and want to express them and do remote management. So there was a gigantic document that essentially summarized all the challenges and opportunities for OSGi in the cloud. And I think one of the first concrete efforts that actually came out of it was the REST interface. Because to us, cloud was clearly going into the direction of RESTful management, and we wanted to expose a standardized way of using REST in order to maintain and manage your OSGi framework wherever that might be. Right? So I personally worked on this specification back in the days. And the entire idea of it is really, you have a lot of internal state in an OSGi framework itself. Well, maybe not so much in the framework itself, but then you have the bundles and the services and the way how they interact. So can we express that in a way that it can be exposed through a RESTful interface? Now, if you know REST a little bit, you know that everybody is using it, but most people are abusing it as a kind of cheap RPC mechanism that happens to travel well through firewalls. The core idea of REST is really to express all this state in the form of resources, right? And that way of thinking was something that I tried to truly implement in the REST service. So the end goal of this effort was to have a platform and language independent way to do remote management so that it could actually be implemented by, let's say, command line tools that would be running locally and you could manage the cloud, or that you could easily embed it into web interfaces, or that you can even use it as logic inside your application in order to trigger something on another machine. And I did the what is it called? The reference implementation together with the specification. And we will eventually ship it with Concierge 5.1 that is now finally up for release, right? So let's look a little bit into the architecture of the REST service. As I said, the entire state of the framework is expressed through resources. So we have the framework itself, which doesn't really have any state. We have a state resource of the framework. Well, that is just an alias for the state of the system bundle, unsurprisingly, right? Because the framework is represented to the application in the form of the system bundle. And then we have things that are actually stateful, like for instance, the current start level of the framework, right? Or other things, the bundles, all right? The variety of different bundles currently installed. Or we have the services here, right? And now each of these resources supports, a subset of the different HTTP actions to be either retrieved or manipulated through, right? So if you think about it, bundles is the set of all the bundles installed, and consequently, if you want to install a new bundle to a running OSGi framework, the most true thing to the RESTful principle is that you post to the bundles collection, right? Because post adds content to an existing resource, right? And for instance, if you want to update an existing bundle, then you just put to this bundle, right? Because put updates and does not append. So, and of course, get is always the operation that gives you the internal state. So if we look into one concrete example, we have, for instance, the framework start level resource. And in the specification for all of these resources, you can see first the subset of verbs that are supported by them. So you can do a get, and that gives you the current start level. And you can do a put, and you can send data in a specific format to your OSGi framework over REST. And then you will essentially trigger a state change, which is the framework start level will be adjusted. And unsurprisingly, this is kind of asynchronous, so you get a result back, which indicates that either the action has succeeded or that it has failed. Because indeed there are a variety of different interesting ways in which you can use this interface that is not okay. For instance, setting a framework start level to an integer smaller than 0. Right? So all of this hinges on the resource, but then we also have representations in REST. Right? So if you, for instance, do a get on the framework start level resource, you will get a framework start level representation back. And we have also standardized how this is supposed to look like for two popular ways of expressing representations, and that is JSON and XML, if you happen to be on that side of the spectrum, right? And you can see you will get back such an object here, which has this current start level set to 6 and the initial bundle start level set to 4. And now if you do that, you can adjust the value and, you know, put it back to the resource, and that will trigger a state change in your framework. And that works equally for JSON and XML. And in the true fashion of, you know, essentially HTTP, the representation that you get back depends on what you have stated in your accept header that you would like to receive. So if you state that you want all things JSON, then you will get that. And if you want XML, you can also express that. So at this point, we could show you a little demo of a running REST service.
So let's switch to the IDE. So first of all, I created two simple components and two simple bundles that we can deploy in our frameworks. First one is just a service implementation that just implements like a simple hello service. And then we have a second bundle, which is basically a simple servlet that just visualizes whatever you do. So we have two bundles, one providing a service, one consuming a service. And I also have here a framework running with some basic bundles and also the REST service here. So now we can actually interact with this framework. So we can, for example, query which are the bundles here. There are 12 bundles. You can inspect the state of bundle 0, which is in fact our concierge framework. You can also look for services. So, for example, service 3 is actually the resolver service. So concierge also provides you with an implementation of the resolver service, and this way you can basically inspect your running system.
So maybe one thing that I can mention here is if you can go back to maybe services or bundles, this is kind of the narrow interface, right? Because what you get back is essentially the set of all sub-resources that exist, so relative URIs that point to all the bundles or services in this case. And that is very useful if you want to display state in a lazy fashion. So for instance, you show a selection menu from which you can pick and then drill down, right? Or if you happen to be in an embedded environment where you know, bandwidth consumption is an issue. You can also just add I think representations, and then you essentially get all the individual bundle representations immediately materialized in a collection. And that might be something that you want to consider if you're in an environment that is not constrained, so you get all the data at once and you don't have to send multiple requests in order to retrieve.
So now let's install a few bundles. So we will do a post then to the framework/bundles. There we go. And as a request, we just put in the URI where we can find this bundle. So this should then indeed install a bundle. It says okay, now we have bundle 13. I can also install UI bundle, send request, and it says now we have bundle 14. If I send the request again, for example, then it will say, oh, there's a conflict because there's already a bundle installed with a symbolic name in this version. So you also get like the feedback if you're doing something wrong. So now we still have to start our bundle. So we had bundle 13 state. If we look it up, this is state 2, so which means installed. So we still have to install these and start these. So we're going to put them in order to change the states. And this, we use JSON, setting state to 32. go. And same for bundle 14. There we go. And if we now go to our example, hello, we're there. So this basically shows you how you can inspect your running framework over REST, install bundles, change their states, inspect services, and so on.
Okay, so as part of the reference implementation and also as part of the specification, we have also provided two different client implementations. The first one is in Java, and it works both as an OSGi service and for standalone. For instance, if you wanted to write a command line tool in Java. And what you get is essentially a REST client factory to which you have to provide the base URL to a remote framework. And then from there, you receive a REST client instance, and this one has a variety of different methods through which you can directly interact with the framework. And we decided to essentially reuse the DTO representation at the Java level. So for instance, if you would install a new bundle, you would receive a bundle DTO in response to this action. And now you have all the information in place to further interact with it. And as I said, the REST client factory is either a way in standalone Java to get an instance, but you can also register it as a service. And then you can use it within an OSGi framework as a service. Now, I promised that we wanted to aim for language independence. So one language is not really proof of that. We also went through the interesting effort of writing a REST client in JavaScript. And this one has a slightly different style that is more true to the language because it uses more like of a asynchronous callback-based or promise-based mechanism to interact with the framework. So we have an OSGi REST client object that you can instantiate. Again, you give it the base URL, and then you would install a bundle by giving it a bundle, and also a callback structure here in which you have a success and a failure function. So in case of success, you will receive a bundle representation object from which you can now retrieve the identifier and pass it to start bundle so that your bundle gets actually started and not only installed. And on failure, you will primarily get the HTTP code so that you can further inspect what the problem was. And then in case the root cause happened to be a bundle exception, we also have a bundle exception representation. So you would get such an object because maybe if you're intimately familiar with OSGi, you know that bundle exception has an internal state integer, which gives you further information on why the bundle exception happened. And we also expose that through the interface, right? So you might wonder what bundle is. Well, in JavaScript, you're in a weakly typed environment. So bundle can be two different things. Right? It can either be a URL or a string. And in this way, you're essentially pointing the remote framework to a location to retrieve the bundle from, or you can just essentially send an array of bytes. And that way you can ship an actual bundle jar over the REST interface and have it installed. It's the same function in JavaScript, of course. And this is also available as part of the reference implementation and could, for instance, be used in a web page to create a rich client to interact with the framework.
Okay.
All right. Oh, yeah. And again, all of this is documented. So if you want to find out how to use these functions, there is a chapter in the specifications where you can see which versions of arguments are accepted and what the resulting callback specific behavior is. Yep.
So this is all cool. So now we can actually have a remote framework and kind of inspect it and install some bundles on there. But of course, this is not really the ideal situation for all the use cases because for first reason, you need to actually have a server running on the device exposing the REST endpoint, which might be a bit overhead for your use case. So why can't we just use the OSGi service layer, or why can't we use, for example, remote services where you're not tied to any protocol, so you can kind of figure out your own very lightweight protocol to talk with your device. You're also limited to a single OSGi framework, so what happens if you want to have a cluster of OSGi frameworks that are interconnected and you want to manage them all at once and deploy a bunch of bundles on some of the nodes? And it's also limited to OSGi specific information. So you can query some bundles and services on the framework, but for instance, you have no idea of what is the underlying hardware, what is the load on your system, while this might also be very useful information that you want to query. So then we went for the cluster information specification, which is basically a new spec in R7. And it consists of two things. First thing is kind of a present service, which just says, hello, I'm here, I'm a framework. And we have two instances of that. We have node status, which can basically represent any entity for which your cluster information implementation knows how to query its properties. It also can be a framework node status, and the only difference is that this indicates that the node you're talking about is actually an OSGi framework. And in case it's a framework node status, it also implements the framework manager interface, which is basically a one-on-one mapping on the REST API you just saw, but then just as a regular Java interface. So then that gives you the methods to kind of query the bundles or install a bundle and start and stop and so ever. So what's about these node status services? What are they for? Well, as I said, they just indicate there's some presence. And if you combine this, for example, with the remote service admin, with the discovery mechanism, you can that way kind of automatically discover all the nodes in your system by just having like a bundle that imports all the node status services, and then RSA will automatically discover them and import them and give them to you. And the node metadata is actually exposed as a bunch of service properties. So you have a unique identifier. For example, if you're on a framework node status, or if it's an OSGi framework, this is typically the UID of the framework. If your nodes represent something else, maybe a Docker container, this might be an idea in the Docker world. But then it becomes, of course, application specific, and your implementation has to figure out what's the sensible ideas. It also can provide some information, some location information, like what is the country or the region or the zone that this physical node is residing. This might be handy, for example, in the cloud environment, where you typically know this information from your cloud provider. You also can expose some endpoints, like how can you communicate with these nodes. These might be private endpoints. For example, if you have in a cloud infrastructure, you often have an IP that you can use to communicate to nodes within the cloud, but not to the outside world, or public endpoints that you can use as an IP address that you can use to actually query it from the outside world. And you can also add some tags which may be application specific. So these are just plain strings that you can use to kind of indicate this is a special function or a special tag that I want to give to the node. It provides one method besides the services, which is kind of a metrics method, which gives you back a hash map of strings. And this gives you some metrics about the node. So depending on your implementation, this could give you some information on the loads of your system or on the memory usage. Typically stuff that changes over time, so you might have to poll sometimes to see what the current state is. You cannot really expose this as a service property, because then your service has to change all over time, which is not really what you want. And as I said, this is tightly integrated with the remote service admin specification, so we rely on an RSA implementation that kind of does the discovery, make sure that everybody imports them. And also, if you're, we specify that if you're within some nodes of a cluster, as meaning all the nodes have like a cluster information nodes status there and indicating I'm part of this cluster, then we enforce that RSA should import and export automatically all the services within that cluster, so you can easily discover and import all your application services there. And then the framework manager is then like a mapping of an OSGi framework management interface. So it's similar to the REST API, but then as a regular Java API, and you can use it to list your bundles and services and install and update the bundles. So let's go for another demo. So in this case, I actually created a little cluster with 2 Raspberry Pis lying here on the table. So I can, let's see whether it still works. There we go. So we have 3 nodes in my cluster. I named it ECE cluster. So for every node, I can now query the properties that are there. So this is a cluster. Yeah, it's a concierge vendor. Just name it like that. They are residing in Germany, in the Ludwigsburg region, and I added a tag there to indicate these are the Pis. I also have one node which is the provisioner, which is basically the node running on my laptop. So that's where I will issue some commands to install bundles, for example. I can also query the metrics. So for example, this Pi has 4 available processors. So these things are just the things that are available from JMX, but you could kind of implement whatever metric you want to push out there in your implementation. So you can see this one has 4 available processors. So this is probably my Pi 2. If I look at the other nodes, then this only has 1 available processor. This is my old Pi B+. So in order to install some bundles now, I wrote this small provisioner command, and there it is. And so what I do here is, first of all, one of the nice things you can do, of course, if you want to query your nodes, you can actually use the target filter and use the tags to kind of filter out the nodes you really want to target. So for example, here I say, I want to deploy stuff to my Pis, so I only want to have any node with a tag Pi on it. So this is totally application specific, so you can basically use whatever tag you want in whatever use case you want. And then I have here a provision command, and basically what I do is now I install my UI nodes on one Raspberry Pi and a service implementation on the other Raspberry Pi, and then automatically these should be connected through the remote services implementation, and it should still work out. So let's test it out. So let's hit provision. There we go. So now if I list the cluster, you can see there are some additional tags here. And this is also something cool, is that you can also kind of inject tags in your nodes by just exposing them in your bundle. So for example, if you look at my Hello Service implementation, it has this property saying, I have some additional cluster info tags, meaning being hello, and the UI has some additional tags being UI. And these are automatically added to your to the tags of your node status service once you deploy the bundle out there. So now let's see whether my Hello service is actually there. Probably another port. There we go. So now it's actually again running, but now I guess I also have a command to list the bundles. So on this Pi, I only have the service implementation. And on the other one, I have the UI bundle and also the API bundle, because the remote service API needs the API in order to import the endpoint. And it also installed the HTTP whiteboards on that Raspberry Pi in order to offer the servlet. So,
all right. So we just want to introduce you to our project, Eclipse Concierge. We might be the only Eclipse project where all committers are at the conference, because it's the 2 of us, and then Jochen in the first row is also here. So we are working on this OSGi framework that is particularly tailored to small and embedded devices by trying to keep the footprint low while still offering currently the entire R5 functionality. R6 is almost done and we hope to have it released in the near future, and we will be working on an R7 implementation coming after that. So your takeaway message is hopefully that there are interesting and various different ways of managing frameworks, OSGi frameworks in either IoT or the cloud. We have 2 reference implementations for 2 standards in the Concierge project, and they will get released with 5.1, but you can already download snapshot builds which contain them for both REST and cluster info. And we hope that you like them and check them out. And with that, we would like to thank you for your attention and are happy to take any questions.
Do you have any questions for
Yes?
Jan and Tim?
What about the REST services? Have you written them your own, or because things like Jersey and so are a bit bigger than your total footprint?
I used RESTnet in order to implement them, but you can pick any platform that you like, right? So it should be implementable on anything that supports essentially HTTP. So you could even use the OSGi HTTP service to implement them.
I was just wondering about using REST, because it's usually all the frameworks are quite big.
Yeah, RESTnet is decent. We run it on the Pi and it seems to work fine. It does not, start up in a fraction of a second. You actually see, 1, 2, 3 seconds delays until you finally have the port open and you can interact with it. But footprint-wise, it's good enough for those class of embedded devices that can run Java. Yeah.
And if it's too much of a footprint, you can always use the cluster information spec and then use an RSA implementation that might be more lightweight than a REST API.
Yep. Other questions? No? So, yeah.
What is the footprint of the cluster information spec? So how big are the ones?
I don't know by heart, but since it's pretty simple implementation, it's just exposing the whatever the bundle context gives you in a framework manager service, and also exposing the service properties in one service registry. So I don't think it's that much. It's just like the API classes and then basically the activator that registers everything.
Yeah. For REST, I'm pretty sure it's under a megabyte with everything in. And that is even with both XML and JSON support. If you can eliminate one of the two, you save. And one thing that I didn't get to talk about, there is also an extension mechanism if you want to plug in your own RESTful APIs to at least make them discoverable through the standardized REST endpoint. Other questions?
All right, well, thank you very much.
Thank you.